more like realistic domain with slow, expensive rollouts, we worked with AMD, who is launching a new neural processing unit. So this is a new chip. There's like no documentation about it on the internet. They just gave us 100 pages of like PDFs and example code. That's the programming manual for this thing. And we wanted to, to give you basically a language model that can code kernels on it. And they gave us this benchmark of kernels. So the black bars here were just writing a model that can attempt the task with up to 10 tool calls. And then this is giving it a RAG over the manual. And this was, I think, like GPT-4 or 5 or something. It was a pretty good model at the time. And so it got up to 16% vector utilization. That's the performance metric we want to maximize. And then this is the old prompt optimizer we had. And then this is with JEPA, again, in just a few thousand attempts at this. This is slow to do because the compiler takes like a minute and you got to run and benchmark all these kernels. So that's why we wanted a sample efficient optimizer. It got up to basically 30%. And again, this is the prompt it found. And again, there's some really cool stuff, I think. Like, for example, headers and imports don't include adf.h. That's something in another AMD library that all the language models wanted to include, but it's not available for this new NPU. And then another cool one is vector operations. Use AIE vector and so on, but do not use exp and store because those are not real functions. But when the language models saw the ones that are in the guide, it assumed these also exist. So it kept making that mistake. And then it even gave it a nice like starter kernel and stuff to do this. And as you keep running this, it just learns more and does it.